Okay, this video is going to contain the examples for week 4. These are going to be the same exact 3 examples that we reviewed at the end of the week 4 lecture. However, I will be pulling up the registers and stepping through the code so that you can get a better picture of what's going on as we execute these commands. And I think it's really important to understand what's happening and what's going on in the registers, because I think if you have that understanding, it will make writing the code easier, and it will also make it easier to troubleshoot and to check that your code is doing the right thing. So before we get started, just a quick note on comments. So you can see this comment on line 7 is a little bit long, and there's 2 things I can do to fix that. So I can hit enter, put it on a new line, and then of course I want to put a semicolon in front. And so a quick note on these 2. When you have a line that is just a comment, you can't tab it over. However, if I put this back, if there's a command or anything else on the line, I can tab it over. So just a quick note on that. Okay, the other way to be able to see more of these comments is these 2 little informational boxes. They both have a hide now button. If you click that, you can see more of your comments. So I'm still missing part of it, and I can scroll over and read the rest, but that's kind of a pain. That's not really convenient. So let me go ahead and put that comment on a new line. I also have an unnecessary gap here. I'm going to get rid of that to clean things up a little bit. And now we'll get into our code. So I'm just going to hit debug, and you'll see that we go into our debug screen. And I'm going to open our registers. And the format right now is in hex, so I'm going to change that to decimal because that's what we programmed in. The numbers that we're putting into our registers are decimal numbers. So to make our lives easier, you'll just want to make sure this format over on the right here matches. So DEC for decimal. If you're in hexadecimal, everything will show up as hexadecimal numbers. If you're in binary, of course, you'll have to try to read binary numbers. And so decimal is just the easiest thing to do to check. Okay, so our first 2 registers, we have our C for our carry register, and we have Z for our 0 register. So in this example, we will be noting our Z register. And the good thing about the registers too, what I like about this compiler is that you don't have to scroll through every single register. It just brings up the registers that you're using in the code. So that makes it really convenient. Okay, so now we're going to step through our code. So we're going to clear our registers, and that's why the 0-bit is flagged. And of course, there was nothing in these registers before, but now we know there's nothing in them. And now the next line will move the value of 3 into register 5. So I'll click step and we'll see that. And you can see it lights up in red over here. Line 3 of the code moves the value of 3 into register 5. Now the next line is going to add the value of 2 to the contents of register 6. So nothing was in 6 to start with, so it just gets 2. And then the next line is going to decrement our counter register B5. So you can see it goes from the value of 3 to a value of 2. And then we're going to jump back up, or this should jump back up to label 1 because the 0-bit has not been set. B5 is not equal to 0, so our 0-bit isn't set. So if I step through that, we see that the line highlighted hops back up to line 5. And so we're just going to add 2 to B6 again. So instead of 2, it is now 4. We'll step. And then so this next line 6, just decremented B5. So it went from a value of 2 to a value of 1. So it's counting down each round. Now it's still not equal to 0, so the 0-bit hasn't been flagged, which means we'll loop around again to label 5. And so again, we're going to add 2 to B6. And you can check in your registers. It goes from a value of 4 to a value of 6, as it should. Step through again, we decrement B5. Now this time, because B5 was 1, and we decremented by 1, B5 is equal to 0, and you can see that this triggers the 0-bit. That's that second column here. So now in line 7, our jump if not 0 condition is not fulfilled. The 0 bit is triggered. And so that means that this is going to skip ahead to the next line. And so this is just moving the value in register 6 into register 7. So when I step through, we see that pop up, and then I'll step through one more time, and we end our program. And so that is our example 1. Now I'll click over to our example 2. Before I do that too, just a reminder, if you need to go back and edit your code, if something in the registers doesn't look right, hit this red X over here in the top right corner, and that takes you out of the compiler mode and back into your edit mode. Okay, on to our example 2. So in this one, remember that we're going through essentially the same motions of setting a counter register, continually adding 2 to register 6. Only in this one, we move the value over and then we jump back and we reset our counter and do it all again. So let's see what that looks like. So make sure you switch to your registers tab, format in decimal. Okay, so we'll step through our first line. We know we're just clearing our registers. We're going to move our value of 3 into B5, just like we did before. That'll be our counter register. And then we are going to add 2 to B6, same as last time. Decrement B5. We got our counter going again. Jump to label 1. And we're going to keep repeating this, just like before. Okay, so we've gone through this a couple times, and we can see we're at the point essentially where we were in our last code, right? B6 is now equal to 6, B5 is now equal to 0, our counter is empty, and the 0 bit is flagged. So because of that, we will not jump back to label 1. It will move on to the next line. And so the next line, again, same as last code, is going to move the value of B6 into B7. So we're just duplicating that in another register. And now this is where the second jump command comes in. Now instead of ending the program, it's going to jump back up to label 2, and it'll reset that counter. So as I step through, you'll see that our counter register B5 is reset and has that value of 3 in it all over again. So now if I step through a couple more times, we keep adding, we see that we don't start over again with B6, right? We didn't go back and clear these registers out. That was not part of the label. That's before label 2. So what happens is that B6 starts at the value of 6, and it continually increments by 2. So now it's up to 8. It incremented to 10. It will increment to 12. Now we'll decrement our B5, and our counter is at 0. And so now this value of 12 will be moved over to B7. There we go. So now we see that B7 has the value of 12. And so we can keep stepping through this continually, and what will happen is the counter will just keep resetting. B6 will continually increase by 2. So essentially you are continually adding 2 to register 6, and you're continually adding the value of 6 to register B7 every so often to a certain pattern, right? So we would see 6, 12, the next number would be 18. If I step forward a couple more times, we'll see that 18, and so on and so on. So that's all this code is doing. It's using 2 different labels and 2 different jump commands to perform this loop and this sort of dependent counter setup. Okay, now we'll move on to our last example. This is our comparison example. So I've already went over and explained what's happening here in the lecture. And just a reminder, our comparison command has the jump if not 0 coupled to it. When we compare, if they're the same, the 0 bit is flagged. And so that's what I really want to highlight here. I think that can be kind of hard to picture sometimes. So this highlights that really well and what that process looks like. So we'll step through, we're just clearing our registers. We're going to move the value of 11 into register 5. And now, if you'll notice, we look at register 5 and you see 0B. That doesn't look like 11. Well, the reason is 11 or B is the same as 11, but this is in hexadecimal. And so now I realize that I did not change my format. It is still in hexadecimal. So if I click over, we see the binary equivalent of 11. And if I click over one more, now it's in decimal. So now we'll step through. Oops. See, I went too far this time. I accidentally clicked step twice. And what I really like about this compiler is that I can step back and take it back a line. So let me do that a couple more times. Okay, so we're back to moving 11 into B5, 15 into B6, and now we're going to increment B5, so it's 12, and then we'll compare, and we'll see, does B5 equal B6? And here's where I like being able to see the registers, because it helps, I think, understand what's happening better. It helps you understand, and it gives you a good visual. So we see that B5 does not equal B6, and so that 0-bit flag is not set. And so because of that, our next line is jump if not 0 to label A. So it's going to jump back up here to label A. And let me step through. Okay, and that's going to increment B5. So now we have 13 and 15. It will compare again. Are they equal yet? No, they're not. So we're going to go through our loop. Add one more, check if they're equal. They're not, so we jump back up to label A. Add one more, check if they're equal, and you'll notice now they are equal. They're both equal to 15. And so let me step through one more time. And so now the 0-bit is flagged. And so because the 0-bit is flagged, we can't jump back to label A. We can only jump to A if there is no 0, if the 0 flag is not set. So that means we'll move forward. We'll put the value 4 into register 8, and we can see that that's being done. And so that's going to be the end of this program and the end of the examples for week 4.